Welcome to Cloud Lunch and Learn, Jonah. So nice to have you.
Yes, same here. It's so glad to be here.
Awesome. So we've got a few viewers live, so that's awesome. Welcome everybody. We're back with our weekly sessions after our Cloud Lunch and Learn marathon event, which, wow, that was a huge event. It was such a great success. Me and the team are extremely proud. We know people are waiting on their swag kits and communication. I know that Hugo right now is emailing people and getting details, etc. And me and Hugo are meeting tomorrow to finalize prizes, swag, etc. So please, everyone, bear with us. We will get there, don't worry. But thank you so much to everyone who joined in Cloud Lunch and Learn Marathon, our first ever event. It was awesome. And thanks for coming back and joining us for the weekly sessions. It's great to be back. And we have Jonah, and we have an exciting thing to announce. Jonah just became a Microsoft MVP yesterday. Woo! So congratulations.
Thank you. Thank you so much.
That's okay. Tell us a little bit about yourself and also the category that you've been awarded MVP in, and share that with us.
Yeah, sure. My name is Jonah Anderson. I work as a software developer consultant at Forefront Consulting here in Sweden. And I'm going to tell more a bit about myself in the presentation, but I'm recently been awarded with Microsoft MVP for Microsoft Azure. So I'm very happy and excited to contribute more in the community.
Amazing. And we've got a few people saying congratulations in the chat.
Thank you.
So yeah, congratulations again, Jonah. So to everyone who is currently with us, thanks again for joining. What you see here on the screen is, if you've not been with us here before, you can scan the QR code or click the link there. So let me just put the link into the chat. And if you register to this session, you will get free learning materials from Microsoft related to the session. And also it shows Microsoft, who kindly sponsor us, that people are taking part in the Cloud Lunch and Learn sessions. And yeah, so it just provides really good feedback from the Cloud Lunch and Learn team to our sponsors, Microsoft, but also you will get some free learning materials. So we always, everyone always loves free things, free learning materials. So if you could please register, we would really, really appreciate it. But with that said, I am going to hand over to Jonah to kick us off with her session. So over to you, Jonah. Have a great session. I'll be here in the background monitoring the chat. If we have any questions, we can chat about them at the end.
All right. Thank you. All right. Hi, everyone, to all viewers that are watching us live today. Thank you for being here at Cloud Lunch and Learn. And tonight I will be sharing with you some serverless development with Azure Durable Functions. And I would like to start by sharing a bit about myself. I like photography, so I thought I would describe or tell you about myself in one picture. In a short minute, I will share that I work as a software developer at Forefront Consulting. I love developing with Microsoft Azure, and I'm pretty involved in the community, both in Sweden and internationally, by mentoring and sharing knowledge through public speaking. So as a background, I studied computer science and even agile system development. I'm an Azure hero, and recently I've been a Microsoft MVP that I'm very excited about to share knowledge with the community. And I would like to start my presentation about durable functions, about the queue problem. This is a real life example. For example, I was a few years ago went back home in the Philippines, and I was in Arlanda Airport in Stockholm, and I had the experience that I had to wait on the line in a long queue without the self kiosk, and there was a situation that I wanted to grab a cup of coffee because I like drinking coffee, and I wish at that time in that situation that I could do parallel things or multiple things at the same time without losing my state in the queue in at the airport. So this is also something that is related to programming or software development. Sometimes we have to deal with and work with parallel tasks, and this is when Azure Durable Functions comes useful to us, especially in our software development, especially in serverless environments, because it solves complex workflow problems in a serverless architecture, specifically in cloud platform Microsoft Azure. So, my plan for tonight is to go through a bit about cloud computing and what is serverless, introduction to Azure functions, what are durable functions, the different patterns, a demo. It's my mini project that I've been working on in my at home on my free time because I like learning different technologies and combining them and how they can work together. So I will be showing that at the end of the session, and I will be sharing some learning resources that will be useful for you that wants to get started. So I would like to start with cloud computing. We that works in cloud computing and cloud development, we know that there are different deployment models. There's the private cloud and the public cloud. And we also have the different models like the infrastructure as a service, platform as a service, function as a service, and software as a service. And today I will be focusing on durable functions, which is considered as a function as a service. So, what is really serverless? It is a hype and a trend these days that wants to learn more and build on things with serverless. So, what it is anyway? So, serverless is means that it abstract or it's a full abstraction of servers. So unlike the traditional on-premise infrastructure, you have all servers in one place and you have to take care of that. But with serverless, you don't have to worry about that because the cloud provider like Microsoft Azure take care of that for you and your organization so that your developers can focus on productivity and effectivity. So serverless also is event driven, so you can scale it, you can create it instantly, and its function it is coded in functions and run by events, and it is not really serverless. So as mentioned, there are servers behind it, but the cloud providers are fixing or taking care of that for us. So I like taking desserts or something sweet after a good meal. So I wanted to do a sweet comparison of what serverless is compared with other platforms. For example, monolith architecture, I like to compare it with cake with different layers. We have everything in one place, the servers, the database, and the applications in one place. And we also have the microservices like cupcakes. So you can choose which cupcake you want, but each of them serves its own purpose or function. And we also have serverless, which are like candies that you can just, they are tiny, but it works, it's good enough and it's not so heavy in the stomach, for example. And it's just also in our application development in the cloud. And when it comes to from control to productivity, as you can see in monolith architecture, we have more control. And then as we go farther to serverless, we gain more productivity. So these are the reasons. One of the great reasons why there are some advantages and good things about coding your business requirements into serverless. And why do we need to build serverless in Azure? It's because it enhances our productivity. For me as a developer, it is important that I get the code and I don't waste my time doing maintaining stuff that I shouldn't be doing. So it's really an advantage for me as a developer. And also, serverless allows us to auto scale, which means that you don't have to manually scale your Azure functions if it's needed because of your loads. So you don't have to do that because you can configure it to auto scale. And it has a pay-per-use model. There's a consumption model for Azure functions and durable functions that you can apply. And you can also develop intelligent apps, for example, integrated with intelligent machine learning services in Azure and cognitive services there as well. So it gives you more capabilities if you want to develop it and modernize your app with serverless. And you also have the ability to solve complex problems, just like my Q problem examples. It allows you to run long running workflow and do several things at the same time, depending on the kind of pattern that you use and the problem that you want to solve. And then also, you can integrate it with other services, and especially within Azure and even external ones. So I would like to start with Azure Functions because Azure Functions, and before you can develop durable functions, it is important that you know the basics, at least the fundamentals of Azure Functions. So Azure Functions is a serverless cloud computing service in Azure, and you can code it in C Sharp, F Sharp, JavaScript, and Java. And it's event driven, and you can integrate it with other services. So Azure Functions is actually code driven. So you have the code, and then you have the events and data. And events can be HTTP trigger, a blob trigger, or events from your IoT device. So you can use Azure Functions to code your serverless methods, and it's composed of code and events and data, and you don't need to maintain the servers or the virtual machines behind this logic. And as for the pricing models, the pay-per-use model uses the common consumption plan. This is the serverless, so which means that you only pay for what you use. But there's also a non-serverless plan for Azure Functions, which is the app service plan. If your organization wants to have a monthly budget, so you can use app service plan. And there's also the premium plan that allows you to have maximum performance and other premium capabilities. So these are the pricing models that you can choose from depending on what you prefer. I personally, on my development, I use consumption plan because I want to only pay for what I use. And also would like to make a comparison about Azure Functions. Why do we have Azure Functions and why do we have durable functions? So I wanted to state the two differences. So for example, Azure Functions, they are stateless, which means that when the virtual machines that run in the cloud that are running your Azure Functions will be restarted, it will lose its state, and that cannot be good. Maybe if you want to run long running workflows in your application. And durable functions is stateful. So these are the two difference of what Azure functions are and what durable functions are. They are two things, different things, but they are not concur. Like they're not competing against each other. It's just that it just depends on what you want to use it for, and durable functions is an extension of Azure functions. So durable functions. it is an extension on top of Azure Functions, which means that all the things that you can do with Azure Functions that you can do as well, the same features in Durable Functions, except that you get more in Durable. And you can create stateful and eternal workflow that's long running, that can runs forever. You can stop it in different ways, but that's one of the great features of Durable Functions. You can run it eternally, and it enables you to solve some complex problems. You can code in different languages, and it also allows you to create a sub orchestration within your orchestration. So it is they are actually good stuff. So when do we need to use durable functions? So you cannot just hey, I want to code serverless, I'll use durable functions. You cannot just do that without identifying first what you really need durable functions for. So, as mentioned, long running workflows, if you want recurrence intervals, if you want to manage the life cycle of your tasks or methods, and if you already have multiple parallel Azure functions in your application or your system, you might as well use durable functions because you can control your workflow and the orchestration of that. And if you want to retry function activities without losing its state, and also if you want to develop serverless functions locally in your machine. So the technology behind durable functions is the Durable Task Framework, which is an open source library and a lightweight framework that you can definitely check on this GitHub repo. I believe it is open source and it's open for some updates and contributions. So you can definitely check it out. And durable functions as a whole have different types. So it composes of lots of functions, and there are different types. There's the client functions, the orchestrator functions, and the activity functions. And the client functions, they actually are special because they kickstarts. This is the entry point of the orchestrator. And this client function can be an HTTP trigger, can be a blob trigger, service bus trigger, and an IoT trigger. So this is the starting point of the orchestration. So it kickstarts the orchestrator function, which has the workflow. It has the design on how your workflow should be orchestrated and or how your functions or tasks will be performed. And then we also have the activities. So that acts like a normal Azure functions, and there you work on your logic depending on what you want to do, and also the type of pattern that you want to implement in your solution. So there's also a special type of functions called entity functions, and these are special types of entity types because it uses to read operations for durable entities. And the special trigger that it uses is the entity trigger, and it's only available in durable functions 2.2 and above. And it only supports right now, as of date, two languages in .NET and JavaScript. So the orchestrator is is very important, is the only difference between the Azure functions and the durable functions. And orchestrator plays an important role in the entire process because you need to design it because it controls the workflow. You need to design it in a deterministic way. It is deterministic. So you cannot just be undetermined when you code your orchestrator. And if you want to learn more about deterministic orchestrator and its API, you can check out the link here. And here is a good example of deterministic versus non-deterministic. And on the left side, we see this is like the durable functions with the orchestrator. And the non-deterministic without the workflow, these are like the normal Azure functions that we code serverless on Azure, for example. So here you see a big difference that with your orchestrator, you can control the state of your functions. And determinist normal Azure functions, it can be located in a different Azure virtual machines and you can lose its state. So when designing the orchestrator in your logic, there are some things, constraints to consider, like do's and don'ts. And here are the known ones. For example, since the orchestrator is considered to be deterministic, it's not advisable to generate random numbers or GUID or generated IDs in your code, in your orchestrator. What is recommended actually is that if you want to generate random numbers or retrieve data, you can use, you can do that in your activity functions. And it is also not advisable to access the database or data stores or set up your configuration from the orchestrator. What's recommended is that you can have your activity function to pass. You can pass your configuration to your activity functions. And the thread, of course, the sleep, run, and delay thread actions are not ideal. And what is advisable is to use the durable orchestration context. And do not create infinite loops. It's especially in the orchestrator functions, because you will not just have logical problems or errors, but it will also create infinite bills in your subscription. So if you need to have the eternal orchestration or long running that you don't have to stop, you can use actually the method called context as new. This is also used to create eternal orchestrations. And don't use current date time because, of course, date and time changes all the time, every seconds, every milliseconds. So don't use that in the orchestrator. So there's actually a special time method that's used in the orchestration context if you really need to check the current date time, which is the method called current UTC date time, and it's from durable context. All right, so there are different patterns in durable functions that it solves, actually. It depends on what kind of solution that you want to solve, of course. So the first one is function chaining, and then there's also the fanning out and fanning in, and then the async HTTP APIs, the monitoring pattern, the human interaction pattern, and then the internal events correlation pattern. So for the function chaining, it looks like this. You would need to, it's like chaining the functions so they are performed in sequence. So the function one would need an input from the function two needs an input from the function one, and so on. The next function also needs the input from function two. So they are run in specific orders, and the next function would require the input from the first one. And the next one, actually, here's the function chaining in action. So for example, I started or kickstarted the orchestrator, and then the activity one will be scheduled. And then when it's scheduled, the orchestrator sleeps. And when the orchestrator sleeps, the activity one is done. Then the orchestrator wakes up. And then when it wakes up, it's scheduled the next activity, probably with a new data or an input that it needs. So it's sent as a parameter in that function. And then when it's scheduled, the orchestrator sleeps again. And then the activity two is done. And then the orchestrator is completed, or the orchestration is completed. So this is how the function chaining works in action. So as you can see, the orchestrator, even though it's deterministic in its character, it also likes to sleep, and that's one of the great advantages of durable functions in serverless, because when the orchestrator sleeps, you don't have to pay for other functions that are not running. So you only pay for the task that you assigned or performed in your workflow. So the next pattern is the fan out and fan in. This is also one of the commonly used patterns in this technology. So in this pattern, you execute multiple tasks or multiple functions at the same time, and then aggregate the result into one, and then you can perform or do something else with the result of all the tasks. So it uses, in this code example, as you can see, it uses uh, a method called task await all, tasks when all tasks are done. So it's gonna aggregate the result when all of them are done, and then you can do something else or print out the result, for example. And then we also have the next pattern, which is the async HTTP APIs, which expose synchronous long-running processes over HTTP. So in this example, I have in the code snippet here, I have a method called check if my website is available. And here I have the iDurable orchestration context, and I have a URL of my website, and uses the durable HTTP response to using get method to check the status of my website. So here I have a condition that checks if my website has a good response or not. And depending on that, I can print out my website's content in the background. So this is a simple example of how it works with async HTTP with durable functions. And then next is monitor pattern. It's actually the opposite of async HTTP API. So you have in monitoring pattern, you have the recurring process in this, and you set a timer and settings and when you want to cancel it or you want to do your job. In this example, you have a task that's monitoring a job status and perform its activity, depending on the timer or if the condition is met. And next is human interaction. So in human interaction, it actually requires an interaction from someone, a human, or probably a programmed robot or programmed logic or a timer, for example. You in this case, there's like in this example, we have like a request approval example in which you have a timer that checks that waits for an external event here. Context wait for external event, and if there's no response from someone in a certain time during a timeout, then it does something else, like for example, escalate or call another function called escalate. Otherwise, it does the process of processing it and waits for someone to approve it. So that's the human interaction pattern. So this is pretty useful if you want confirmation from your orders or something, approval. So this is very good pattern to use. And there's also aggregator. Aggregates the event data over a period of time and then put it into a single addressable entity. And then when you work with durable functions, especially with using the HTTP API, this is an example that I had printed out from a Postman. And when you use the HTTP API, you will see different information about the orchestration details. So in every orchestration, there's actually important details behind it. Like, for example, the orchestration instance ID, the URL, the raise event, the terminate URL, and the purge history and restart. So all this information, you can use it in your logic to control the orchestration, like the instance ID, for logging and calling another part. And also the terminate URL, if you want to terminate your long running workflow, you can also use that URL and call it to terminate the entire orchestration. And for those that are interested in developing Azure functions or durable functions with containers or Kubernetes, Azure functions actually support CADA. So you can use CADA, Kubernetes based event-driven auto-scaling. That's the term. You can use it if you want to use serverless with Kubernetes technology. And as for the support for .NET 5, currently .NET 5 only supports the normal or standard Azure functions, but not for the durable functions yet. So as of today, it's .NET Core 3.1 that's supported, but hopefully in the coming .NET 6, maybe the durable functions will be supported. So there are actually some good articles that you can check out. There was a .NET Focus event. They actually announced this roadmap for a .NET 5 durable functions support. And best practices. So it's good to know the best practices so we know how to do things right, especially that we're working with consumption model, for example. So when it comes to developing with durable functions, you can actually use Azure Application Insights to monitor the orchestration or instances of your functions. And it is also advisable that we version our code or functions consciously because it's long running. So you cannot just push your code to the production while there are long running tests actively going. It's advisable to use a side-by-side deployment and even try to do deployment with breaking change. So Azure or durable functions supports deployment slots in Azure, so you can swap your deployments depending on the versioning that you have. And also, I would like to recommend Azure Storage Explorer, which is a pretty good tool to check on the logs and information that you need on what's happening behind the scenes or what's happening behind the orchestration. And there was a pretty good and great article written by someone in Medium. It's about how to some good strategies or advice about a durable function. So the writer kind of like tested different strategies and best practices and durable functions that are recommended to check out. And error handling. So error handling is important. So we can call another function activity. We can use automatic retry on failure that's built in the durable functions. And also the traditional try-catch blocks that we normally use in our code. And automatic retry looks like this. So you have a method that has a retry. You can just call it from the context and send in the parameters. And you can set up the option, how many times you want to retry, and the time span as well as the interval. And another example for error handling is using try catch blocks and then calling another activity. So in this example, we have transfer funds functions in which that you want to debit the account. And if it doesn't work, you have, for example, there's an exception or error, you call another activity to credit the same amount to the source account. So this is a good example. And unit testing, yes, you can also unit test or test your durable functions even though it's serverless. So you can actually use mock framework and XUnit for testing it. So here is an example of units testing for orchestration for the orchestrator, and you can also create unit tests for every activity. So this is a good thing to know when you're developing, that it's available for you. And developing Azure Durable Functions, of course, you need to have the fundamentals of Azure, the standard functions, because they're like family. And you have the option to create it in Azure Portal if you want to do it with the interface on the web browser. You can also use Visual Studio, Visual Studio Code, and the CLI in the cloud, and the core tools, Azure Functions core tools. And for web requests, I usually use Postman or just the web browser. And locally, I also use the Azure Storage Explorer, and that is also available on the Azure portal as well. And as for learning resources, there's a learning path about Azure Functions. And there's also a great channel that I follow, Serverless on Azure, by Mark and Gwen on YouTube. So you can check it out. And I wrote an article about Azure Durable Functions on Dev that you can check as well. And as for developing developer tools, here are the most common ones that are used. And I will be doing some demo now. Hopefully, we have enough time. So I would like to show you my example before I show the code. So what I'm gonna present or my demo project is that here I have an orchestration going on. I called it Serverless Azure Storage Notifier, and the method that I'm using, or the pattern that I'm using, is the function chaining. So my orchestration starts with an Azure Blob trigger. And then in my trigger, I send in my Cloud Blob data, which is like the data of the image that I upload to my Azure storage. And then I will be kickstarting the orchestration or workflow by starting it with a trigger. And the first activity is going to send the message to the service bus with the link or URL of my Azure image or URL where I can access it on the web. And then when I have it, I will be sending an SMS message and even call using the Twilio API. And then when that is done, I passed in an information to my third activity function to send an email to me as an admin using SendGrid and Azure Service Bus. And when it's done, I'm gonna also send. I will also get the service bus messages that are in Azure in the queue and email it to me. So it's kind of like I could do it. I could actually do this in just few functions, but since I'm actually just playing around and learning more on how to integrate all the services, the SendGrid and Twilio in one, I thought it was fun to use the function chaining pattern. So I will be showing the demo soon. But my expected results would be like when the first activity has done its job, then I should be getting a text or an SMS that I uploaded a new file in my blob, and was also added to the service bus queue. And then I should be receiving a call using Twilio and also an email. So let me see if I can switch sharing my screen, if it's okay. Share another screen. So, thank you. Let's see. I will show you my code. Let's see. So, I will just show you my. So, I have a project here. So, this is my orchestrator. And in my this is like, I'm going to show like the workflow, the flow. So, I have like a context. And in my context, I have the HTTP trigger that I have here below. Let's see here. So here is my client function, my starter function that I have like the name of my storage and a connection string. And it is an item cloud block blob. And here I check if I have it is not empty. And when it's not empty, I will be using a starter, iDurable client starter function, and call it using start new async. And the name of my orchestrator, and I will pass in my blob item with this information. And in my orchestrator up here, when it's run and triggered, I will be saving it as like an object. And I have like a Boolean that checks the results of this. So I'm calling another method in line 44. I'm calling another method, like send a message to send service bus queue. And then when it's done, it's gonna do the chain two, which is calling and sending an SMS using the Twilio API. And I passed in the Boolean that says, was it saved to the service bus queue or not? And then when it's done, I'm going to do another chain in which, like, if the SMS was sent and the user was actually called, then I will be calling I will be sending an email to the admin and also get that message from the service bus, and then print out the result that it's done in the orchestration. So I will be running this. Let's see if I can do things. So I will start my code. This one. This is I have to learn how to do and this is my like local file, and this is my Azure Storage Explorer. So I can just drag and drop things. So my application is running right now, so it's ready to be triggered. And what I can do is I can upload a beautiful picture here, and it's transferring data to my Azure storage in Azure. And once this is completed, hopefully it kickstarts the orchestration without any problems. Sometimes it doesn't work when you do demo, so hopefully this one will work in my machine. It looks like it's not working. Let's try again. Let me just stop and try again. So it stopped. Let me try again. Another picture. So it's done, and it looks like it's not running. Wait, I'm sorry. It's so difficult. Let me just run this to rebuild my solution. I'm
Don't be sorry.
sorry.
Don't be sorry. There's nothing like a live demo to give a real
Yeah,
life insight to what's going on.
yeah, it happens sometimes, but maybe there are questions.
Yeah, so
If
there's a question we can take just now whilst you are
Hmm?
doing that, if you're okay to multitask.
Yeah,
Um,
sure.
and yes, I am walking on my treadmill, people. So we have a question from Victor. Hi, Victor. Um, he says, nice presentation. Any experience using Azure Function to call Microsoft Graph API?
I personally don't have the experience of integrating it with Graph API, but it should be possible because it's like Graph API is connected to Azure AD. So I believe it should be possible. It's,
Hello, Stephen Simon. Thanks for
hey,
joining. Hello, Vabav. Hey, Victor. Yes, I'll keep walking.
yes.
That's your entertainment for just now.
Yes.
Okay, so we have another
It
question.
is.
Azure
Yeah.
functions can be called inside a container instance? Question mark.
Azure functions, let me just see that question. Azure functions can be called inside the container instance. I haven't actually have experience integrating Azure functions in container instance yet. So I can get back to Prerit to that if it's okay with him. I don't have the answer right now, but maybe someone in the audience have experience working with container instance and durable functions or Azure functions.
Does
Thank you.
anyone in the does anyone in the audience have any experience with functions and containers? And Prerit, definitely reach out to Jonah on Twitter afterwards. Paul Burns, running is better for you. I hate
You should
running.
run.
I hate running. I look, it's taken me so I was just telling Hugo that I've actually started yoga on a Monday morning. He's been trying to get me to meditate and zen out for some time. So look, I'm walking, I'm at yoga, I'm almost back into the gym. I'll get there soon. But yes, I really should be outside and
Yes.
not inside, but hey ho.
I'm sorry. My function. It looks like my computer is hanging, but I'm gonna do one more
Okay.
try, and hopefully this works. This is like the last part of my presentation, but I prepared for this like all day. I know it works, but it's difficult.
Of course, it works.
It's
It's just
just in my
pressure
machine.
and the magicness of a live demo that interferes.
Yes. Yes, that's why they said they don't recommend live demos in the live presentation. But I'll
I
try
think
again.
that
Let's
live demos
see.
are the best. I think that live demos
Yes.
are the best.
Yeah, it's like you don't have to be perfect. Like it's like the real life
Real
when
life,
you develop.
exactly,
Yeah,
exactly.
I will try to do this again. Hopefully, it kickstart my orchestration. Something is stopping it in the background. So
That's okay. You take your time. I'll entertain people by
yes,
walking on a treadmill.
yes. But anyway, it looks like it's not triggering anything. Something is wrong. But anyway, whatever what it it does is it actually like when I run my function, it will when I upload my blog, it's gonna it's gonna save it to the Azure Service Bus, and then when it's done, it's gonna send me an SMS and a call, and then it's gonna send me an email. And it looks like there's something else that's DLL problem with the security of my computer, maybe. I'm sorry about this, but I can share my screen again. This one.
Also, guys, do you like my new clouds? I've put some new cloud shells on the wall. I've not put anything in them yet. I'm not sure what to put in them, but so everyone
All
says
right.
that you're doing absolutely brilliant. I would agree. I think the cake analogy at the beginning was amazing. I absolutely love when people put this amount of thought and effort into really teaching Azure services and concepts rather than just using like the standard material. I love that. Analogies help me learn so well. So yeah, me and Paul are the same. We're both novices when it comes to this area, and you've done a great job so far. So don't worry about
Yes.
the demo.
Yes, I'm trying it again. It looks like something in the process in my computer that's locking it, and that is I wasn't prepared on the live demo. I'm sorry, guys, but I can send you. I have a copy of the code. So can you share my screen again, Lisa?
Yep,
I have some few things.
sure can.
Sure.
I'll
So
disappear now, but I'll be here if you need me.
yeah, you can stay on the line. It's okay. Now it's working. I wish I could. I wish I could show you, but let me see. Can I share my screen again? It's okay. Let's see which one. That one.
Yep. Here you go.
So it actually kickstart. Look, it's it's kind of like too quick that I didn't share the screen on time. But as you can see, it kickstart the orchestration. I can do the logs here. So here, it got triggered by my blob. When I uploaded one of the images, and here it started the orchestration. And here you see the blob name, the name of the Shutterstock JPEG that I uploaded in the cloud, and it executed the starter functions and started the orchestrator. And here it says in that time frame, it received event data, and it's composing a message, creating it, and sent it to my Azure Service Bus queue. And there, I also sent an email, a kickstart also Twilio to send and receive SMS to me. So I actually got a missed call as well at the same time while sharing the screen. And here I have a log that the blob, an SMS was sent to my number with a message ID, and even also sent a call with that ID. And since I missed answering it on time, so it says that call was not completed because it was like a missed call. And then when it's done, it also finalize it with a message that I also received an email. So if I check my work email, I don't mind if you see my folders anyway, if it's okay with you. So I actually got my email just right now, like a few minutes ago at the same time. So this is the email that I got. So if I click on this, it actually went to spam, and it's me that sent it to myself, but it should be here. So I got an email showing the link to my blog that I can access via email. So this was the image that I uploaded from my computer, this one. So it's ready in the cloud, and I clicked it from the email. And if we want to trace, this is my service bus queue. So the message is not ready in Azure, but you can actually see here in the last are that I had some things going on. For example, 7:58 p.m. my local time, that I actually processed one message through the service bus queue, but it was processed right away using my durable functions. So that's it. I can now switch to my other presentation to just do the final ones. So that was it. That was the result. Even though the demo wasn't perfect, but I hope you learned something. And I wanted to summarize a few things that we learned about serverless, Azure Functions, durable functions, fundamentals of it. And if you want a copy of the repo, we have it, and some helpful resources. So I have actually, if you want to learn more about me and contact me, you can feel free to do that. And I also have an example of the GitHub code and also a presentation copy for this. So thank you so much for listening, and I apologize for the technical problems.
Don't apologize for technical problems. Technical
Yeah, I know.
problems are our life,
I
aren't
know.
they? That's everyone's life. Okay, so everyone, thank you so much for joining us for our kicking off our weekly sessions again. Let's all congratulate Jonah on becoming an MVP once more. So well done. Super proud of you and super happy to have yet another awesome female in tech part of the
Yes.
MVP ranks.
Yeah.
That's honestly.
Did you know that I'm the first Microsoft Azure MVP that is female in Sweden? First female, and
Wow.
so it's good.
It's good. And then it's also concerning that in 2021, there's only one female in Sweden. So definitely big congratulations for that. And then me and you can go on a mission to get more female MVPs. Yes, absolutely.
I'm working on that. I'm working on that mission as well here in Sweden. So we're gonna do it internationally.
Yes, absolutely. Any help I can provide, I'm there. I'm a bit of a strange one in that I'm like not technical, so I'm a non-technical MVP who's potentially trying to become more technical, but I'm definitely here to help when it comes to encouraging other people to go after those kind of dreams. So everyone, if you haven't already, please do register to this session. There's a few things that this does. It lets Microsoft know that people are attending our sessions, and Microsoft kindly sponsored us, so that's awesome. It also allows you to get access to free learning materials relevant to the session that Jonah's just kindly provided for us. So please definitely register. And then also, we would love to get your feedback on our Cloud Lunch and Learn weekly sessions. So posting a link for you to give us some feedback as well. I'm sure it will all be super positive, but it'd be great to hear from you. So thanks everyone again for joining. We'll see you all again next week because we're back to Cloud Lunch and Learn on a weekly basis. Thanks everyone. See you later.
You.
Thanks,
Bye-bye.
Jonah. Bye-bye.
Thank you. Bye-bye.